Hello everyone, I am Bharat from the Department of Areas. I am eager to going to explain MLP multi-layer perceptron implementation. For implementation, we are just choosing non-linear separable data, and in theory, we are just choosing exact truth table for same input. We are just getting different output. For different output, we are just getting one, which was plotted in a graph, and explanation. The graph plot that the two input corresponding to their output, visualizing their plot, we can see the impossible to separate a different output by using a linear equation. Thus, we are just using a multi-layer perceptron, and the output, it was impossible to machine to set up a equation for a good output. The inner layer of the deeper processing of the input are known as hidden layer. We are just using hidden layer in the perceptron multi-layer perceptron neural network is given here. We are just using new input layer, hidden layer, and output layer. In multi-layer perceptron, there is no limit for the hidden layer, so we can take multiple hidden layers in it. But here we are just choosing only two hidden layer with one input layer and one output layer. And algorithm, in algorithm, they are just given the design step, like taking an input pattern for XOR gate, and decide output for the XOR gate array. And I previously explained that they are taking two hidden neurons, and one output in neuron, that they have mentioned. And the program is given in first. We are just importing numpy pandas libraries for input, and we are also importing matplotlib pyplot as plt for visualization libraries. For visualization, we are taking two input array x and y. For x, we are just using 0011 010 as an input for the x target, and y involves 010, which was the output of the input. We are also mentioning the number of neurons for input, output, and hidden layers. Hidden layers, and we are also mentioning the shape of input to m. And learning, we are also mentioning the learning rate as a zero point 0.1. In white, for white 1 and white 2, we are just assigning a random values by using a random function in numpy library. We and also created a loss function with a loss array, created a sigmoid function, forward propagation, back propagation function for a iteration. For a iteration, we are just mentioning at 10,000 by using for loop. We are just mentioned that for previously we created a forward prog and backward prog. By using the same, we are just implementing this in here. And after a forward propagation, we are just updating the weight here by using the back propagation. And we are just plotting the losses and labeling it as epochs and loss value by using the matplot library here. The the mentioned one is here. By increasing the epoch, the loss value decreases to 0.40, that as it mentioned. And also crediting the def predict function to predict the corresponding output for the x again. When we give 1 0, we are just getting 1, which was right, and 1 1, we are just getting 0 0 1, we are just getting 1 0 0, we are just getting 0, which was right. Right one. And also we are just predict printing it as a printing it by supplying it a weight and test data. Test refers to the output data, and weight 1 weight 2 refers to the updated weights from the back propagation. Thus the extra classification has been implemented. Thank you.